In example 3, we're going to start now talking about exponential decay models. Letter A says, at the beginning of an environmental study, a forest covered an area of 1,500 kilometers squared. Since then, this area has decreased, and that's your indication that it's decay model, by 3.75% each year. Let T be the number of years since the start of the study, and let Y be the area that the forest covers in kilometers squared. Our first task is to write an exponential function showing the relationship between Y and T. Whether it asks for an exponential function or model, it's asking for the same thing, and your answer should contain two variables. What we need to find here is we need to know C, which is our initial amount. What are we starting with? So the forest starts with an area of 1,500 kilometers squared. So C is 1,500. Then we're looking for our decay rate or decay factor. So here we have that percentage, that 3.75. That's going to be our decay rate. So we know that R is equal to 0.0375 once we change it to a decimal. And then if we take a look at our formula, we either need Y or T, but again, Y and T is what we want to write our equation in terms of. So this is only the information we need to write that function. And we get Y equal to 1,500 times 1, and now since we're dealing with decay, this is going to be a subtraction of 0.0375 raised to the T. And then from here, you're always going to simplify what's inside. So we get Y equals 1,500 times 0.9625 raised to the T. That's our model, comparing Y and T. And then in number 2 here, it says estimate the area the forest covers in 4 years. Well, T is our time in years. So we are going to evaluate this when T is equal to 4. And we get Y is equal to 1,500 times 0.9625 raised to the 4th. Now make sure you're plugging this into your calculator as well. If you need to hit the pause button, go ahead and do that. But if you plug it in correctly, you should get 1,287 kilometers squared. Since we're talking about area, we're talking about kilometers squared. And again, it tells you that Y is in terms of kilometers squared up at the top. Let's try another one together. Let's take a look at letter B. Letter B says you bought a computer for $1,800. The value of the computer will be less each year because of depreciation. Depreciation means it's going down. The computer depreciates at the rate of 29% per year. Write an exponential model, again, model or function, to represent the situation. So this is telling us again that Y and T should be in our answer. We need two variables that we're looking at in terms of our model. So we need our initial amount. What did we start with? What did that computer cost in the beginning? And that was the $1,800. And then we need our decay rate or our decay factor. And since we have this percent that it's going down each year, that is our decay rate. So we know R is equal to 29% as a decimal is 0.29. Plugging that in, we get Y equals 1,800 times 1 minus 0.29 raised to the T. And then you're going to do that simplification, subtract the 1 minus 0.29, and we get Y equals 1,800 times 0.71 raised to the T. There's our model or our function. And then we want to estimate the value of the computer in 2 years. So that is when T is equal to 2. So we get Y equals 1,800 times 0.71 raised to the second. Plug that in your calculator. Double check your answer with me. If you plugged it in correctly, you should have gotten $907.38. If you have any questions, let me know. Otherwise, you can go to the try this. So go ahead, pause it now, unpause it when you're ready to check your answer to the try this. If you did the try this correctly, number 1, you should have Y equals 2,300 times 0.92 to the T. And number 2, you should have gotten in 5 years. It would be $1,515.89. Let me know if you have any questions.